Okay, now the other part of this question says, also use the lens mirror equation to do that. And here's how you do that. So your lens mirror equation is 1 over f equals 1 over O plus 1 over I. You have to use it twice. Okay, so the first time you have to use it is for your lens 1. It will be 1 over f minus 1 over object 1 equals 1 over image 1. So your 1 over f1, what was your f1? Plus 15 minus your object, which was minus 30, gives you your I1. Tell me what I1 is. 30. And for your magnification, you will do minus I over O. This means it will be I1 over O1. So it's 30 divided by 30, which gives you a magnification of minus 1. Okay, now here's the trick. When you do it for your lens 2, no, in this case, mirror 2, right? You use the same equation, except now you're going to use 1 over f2 minus 1 over O2 equals 1 over I2. What is O2? I said that your O2, that we will use image 1 as object 2, correct? Everything has to be done with respect to the optical system that you are talking about. In this case, mirror 2 is your optical system, right? So in fact, watch this carefully. This is the distance that you now need. Whereas this object I1 was this distance. I1 is according to lens 1. But now you need the object with respect to lens 2. If this is 45 and this is 30, how do you find this distance? 45 minus 30. So I'm going to just erase those. So your object 2 will actually be 45 minus 30. Because now you're doing it with respect to your second part of the problem. So object 2 will actually, in fact, be 15. So then let's solve for it. My f2 was, what was it given? Minus 20. Minus 20 minus 1 over 15 gives me 1 over I2. So what will be my I2? I know it'll be negative something.
Negative 11.6
centimeters. And then what will be the magnification? I2 over O2 with a negative sign. So it'll be minus 11.6 divided by object 2, which was 15.
0.77.
0.77. So we said 0.66, ballpark. You were kind of right. Okay, notice that this I has a negative sign with it. Yeah? What does that mean? I2 has a negative with it. That should tell you it is a virtual image. It is going to be behind mirror 2 now, right? Okay, now can I show you another trick? So maybe, I don't know, question might ask you that this, the second part, whatever that may be, is lens or mirror, is actually not 45 centimeters, but rather, I don't know, here. That suddenly makes your image 1 now a negative or a virtual object for lens 2. Do you see how that works? even though it was a real image for lens 1, it has now become a virtual image for lens 2. This is how you get negative objects. Yes.
So like you would go about it normally for the first object, and then after you finish all that, then.
Yep. So always, okay, here's my hint for you. Always do them in parts. Don't try to do everything at once. You will be really confused. See how I approached it? I only concentrated on the first one. And then once I had all my answers for that, then I put in the second one. Because then the second one will make sense, because now I'm going to refer back and say, okay, my first one was doing this. Ignore everything else that you did for lens 1 and just now concentrate on lens 2. That is why doing those problems that I gave you before is very, very good, because it gives you every single possibility that a question may ask you. It gives you behind the focal length, in front of the focal length, if the lens is on this side, if the lens is on that side, like it gives you all sorts of possibilities. So once you figure that out, then it's just a matter of putting the two together. There is a method to my madness.